Hey guys, this is our third lecture for ME 397 thermodynamics. I'm going to talk about manometer and pressure, solve one example in this lecture and the second example in the following lecture. So far I hope that you're all doing a good job in the course and you feel comfortable with the materials. Please let me know, send me an email if you have any concern. So I assume that you have done the reading assignments, the chapters and the lecture notes, and as I mentioned before, meanwhile that I'm talking about this lecture, I'll mention some pages of the notes. So please pause, go there, read the page again to keep it in your mind, and then come back to the lecture, play, and then listen to the rest of it. So there's been some changes on the blackboard. Let me go over them first. So here are the announcement page, and I will post all the news and everything here, and you'll be informed by email as well. In the content page we have the lecture schedule, that it's where we communicate, and then I tell you all the plans and what happened so far. So it has been updated today, and the only change is this assignment first that was submitted today at 5 p.m. So the solution will be available tomorrow 5 p.m. So let me close this page. Here we have first one, lecture material folder. It's divided into 3 subfolders. This is the video. All these lectures will be posted here. I mean the address of the Google Drive. So if you click there, it sends you to the drive that I shared with you. And then here we have, and then here we have the lecture notes that I'll post. They're all a summary of Dr. Schrott's lecture notes in the course that you had this semester, and also the examples that I go over in the lectures will be posted here. So for example, see, there are 2 examples, 1 and 2, about manometers, that in this lecture I'll talk about this one, the first one, and in the following lecture I will solve the other one. Okay, back to content. So here the homework assignments, I posted the first one that I told you before at 5 p.m. The solution will be available in this folder here tomorrow 5 p.m. and here's your assignment. Here are 3 examples, 3 multiple choices about mostly conceptual questions, and then 4 other examples and problems here. So you have the answers. The final answers are provided here, unless just the last one, it doesn't have the numeric answer, it's just parametric. And all these, so again, let me mention that you will not be evaluated based on the assignments. They're here just to help you, and you do not need to submit your work. You just can work. I mean, you're supposed to work on these because the final test questions will be similar to all these questions, so it's very critical and helpful. Go over these questions, and then in the solution that I will post, you can compare your answers with the solution manual. Okay, so again, let me go back to lecture material, lecture example, and this is the first question that I'm going to talk about now. Please keep this page on your screen in front of you meanwhile that I'm talking about the question, because I will refer to some numbers and some information provided in the question. So I assume that you have it in front of you. Yeah, please, so keep it somewhere on your screen. And I have it here in front of me. So let me go back to my note. Okay. So example 1. Great. It says the water in a tank is pressurized by air. Hold on a second. Let me tell you something. So when you want to solve a question, you need to pay attention to every and each sentences. By this first sentence, you can imagine that you have a tank, and so there should be like a combination of water and air. Please pay attention that it's air, it's not vapor. Well, although we know that water will evaporate, but I mean, pay attention to the words, not the reality. So it says air. Okay. So we can imagine. You can imagine that we have water, it's below, it's heavier than air, and there's air on top, and the air is pressurized. So if you mess up with this tank, it might explode, for example, if the pressure is high enough. So please, before you solve your question, imagine the story. Okay, this story can be force, can be pressure, or a movement. For example, right? So, for example, a movement. What do I mean by a movement? Let's say we have a piston cylinder device, and it says that the piston is moving downward. So if we keep this in mind, so we know that the volume is shrinking, right? So let's say we solve all this question all the way to the end of it, and then we find delta V as a positive value. So it means that volume increased. So it expanded. But we kept in mind that the piston was moving downward. So there's a contradiction. We made a mistake somewhere. So it helps you to confirm your final answer. That's why I'm telling you that imagine the story. Just keeping in mind what's going on. Okay, thank you. So water in a tank is pressurized by air, and the pressure is measured by a multi-fluid manometer as shown in the figure. So you go to the figure, it's water, air, in the below there is an opening to the manometer, it's connected to the tank, and then it's water all the way H2 up to the interface with the oil, it's orange color. Then you go again, take the other turn, and then come downward, and then you get to this interface with mercury, and then go upward, and then it's air, it's exposed to the atmosphere. Okay, so determine the gauge pressure of air in the tank. So a gauge pressure, what is it? So if you check the lecture note number 2, page 5, you see the description of the gauge pressure, absolute pressure, and vacuum pressure. So the gauge pressure is the absolute pressure, the pressure of a point with respect to the atmospheric pressure. So basically, like it's like, to make it more simple, you just need to subtract the P gauge equals P absolute pressure, P absolute minus P atmosphere, right? So somewhere on the figure you have a domain, or you have like a spot that at this domain or spot pressure is at atmospheric pressure. That here at the very right end of the manometer at point 2, you can see that it's exposed to the air. Not air, is like the other one. No, it's exposed to the atmosphere, right? So when the question is asking for a gauge pressure, somewhere you need to keep in mind that on the figure somewhere we have the atmospheric pressure. Thanks. So Another point that I want to mention here is that it says determine the gauge pressure of air. Okay, gauge pressure in a fluid does not make sense. So gauge in a fluid does not make sense unless you specify the position. So you need to say that exactly which spot or where are you interested in to find the pressure, right? Why? Because we know that in the air, for example here up above the water, everywhere in the air the pressure is the same, right? There's no hydraulic pressure. But as you go through the interface, there so let me go here. So here on these points, right, pressure is all the same, right? And you can define a gauge pressure in the air. But then as soon as you pass this interface between the water and air and you swim downward into the water, then this hydraulic pressure increases and it adds up the pressure on top. So then you cannot say gauge pressure unless you say at this point or exactly where it is written water. Tell me the gauge pressure. Then I know how deep I'm in the fluid. Okay, so back in our question, let me show you. So here it is asking us for the gauge pressure in the air, but we know that everywhere here in this tank up there, I mean in the air, the pressure is the same. So on the interface the pressure is same as the rest of the area in the air as well. So including the interface and the air, all pressures are gauge pressure. Okay, great. So now let's draw let me go back here. So we are here, it says determine the gauge pressure of the air. So we need to find how much is the pressure on the interface or in the air. Okay, great. Now I want to pick a question, pick an equation and then solve the example. But before you solve an example, a question, you need to clarify remember that I mentioned before when I was defining like system and stuff, we need to know exactly what are we gonna talk about. Are we gonna talk about the tank body? Are we gonna talk about oil or air or water or me? I don't know. You need to mention that what is your system. Is it open? Is it closed? In terms of mass. You need to mention, you need to specify exactly what are we going to talk about. So when you determined that, then draw your system separately. Then you need to draw again the portion of the main figure that you're gonna talk about. You're gonna solve, I don't know, the force, pressure, temperature, volume, whatever. You need to draw that again somewhere. That I am going to do this. Oh, sorry. Oh, what happened? Never mind. Yeah, I'm gonna do this for you. And the third step is write the question. The question is, how much is P gauge in the air? Okay, great. Now I'm gonna draw my system. Please pay attention. I am gonna draw just the system, right? My system is here. My system is are the fluids. So I should pick the block of water and the manometer Okay, here's a question. This line here, this line, you can see here, what happened? Did I miss it? And also there. As I mentioned before, when you are drawing your system, you need to clarify if it's an open or closed system, control volume or control system, control mass. And the boundaries are either real or imaginary. As I told you, I'm just picking the water. So up there, it's just an interface between water and air. So I need to draw an imaginary boundary, right? And likewise there, it's exposed to the air. So this dashed line is imaginary boundary, but the rest of the lines are real. They're walls. Okay, here like the tank is metal, the manometer is glass, perhaps. So I have these interfaces, right? The whole part this is water, here is oil, and the rest is mercury. Okay, so, and this is, as I said before, this is the interface between water and the air on top of the tank that I excluded. I took it off the figure. Here I have the orange is the oil, and then this is mercury. Oil and then mercury. So back to these steps. Write the question. Okay, the gauge pressure at the air. So as I said before, the gauge pressure of the air is equal to the pressure on the interface. So if I pick a point here, point 1, right? This is exactly what I'm looking for. I'm looking for, so P1 pressure at point 1 is equal to P air, right? I'm looking for P air. So P1 on the interface is equal to P air, the gauge pressure. Gauge. So the next step is specify important points. Okay, how do we do this? Oh, I'm sorry. 1 second. Okay, so you need to travel. I know this. Oh my God. You need to travel oh God. I'm so sorry about this, but for some reason it's not. This is not. I hope. Okay. Travel through your system toward a known point. I'll tell you what this known point is. And pick your points at the interfaces. That's it. And this known point here. So tell me, please, what on this figure, there is a point that we know exactly how much the pressure is at that point. It's there, right? It's here, the opening to the atmospheric pressure. So we know that we have this known point in our question. Opening to the atmospheric pressure, P-A-T-M, right? Okay, so I know that here the pressure is atmospheric pressure, which is all the way equal down to this interface. It's just air filled up with air. So now I need to go through my system and then pick the points. Okay, let's start from point 1. Point 1 is on the interface up there in the water. Now swim down, go down, 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 go through this opening. Oh, perfect. Then go. Wait, here's my interface, point 2 with the oil. And then go through the oil. Okay, great. Very well. Now, okay, here, interface with mercury, point 3. Okay, let's swim again. More. Go. Oh, yeah. Interface with the atmospheric pressure, point 4. Oh, we know. We know that P4 is P atmosphere. Great. Now, what's the next step? Now, let me tell you a trick. Well, I need to mention 3 pages of the lecture here. So if you to lecture note number 2. Please check pages 6, 11, and 12. Thanks. So you can just check it now and then come back to the lecture to watch the rest of it. So now perhaps you have read all those pages again. Great. So now let me tell you the trick. Okay. Here is the trick. That's it. Simple. So if you go toward the gravity direction, which direction is the gravity direction? Here is downward, because unless everything was like floating, as I don't know if, of course, you have seen those videos on the YouTube that like these people on the space station, they're like floating, they cannot drink water, because then if they rotate a glass, like it doesn't, oh, they have a lot of problems up there. Anyway, so we know that the gravity direction is downward. So simple. If we go down, we add the pressure. If we go up, we deduct the pressure. That's it. And we need to start from the initial point. We go to the knowing point, the point that I told you. So the initial point is point 1, and the last one was point 4. That's it. Let's write it. So the initial pressure was here. Where is it? P1, then P2, P2, 3, and 4. Okay, and then so I write, so P1, I want to go to point 2. Okay, so if I swim all the way down and then I pass this opening and then go there, so in total I have moved downward from point 1 to point 2, right? And the depth is, let me draw it with green. The depth, the total depth is H3. Oh, sorry. Is H1. Okay. So from point 1 to point 2, we need to add the hydraulic pressure, rho G H1, and it was water, so rho, the density of water. Okay, great. Now let's move to point 3. So again, from point 3 we go up and then down. So in total, again, the total depth is H2. Okay, and it's oil. So we went through oil. Previously we went through water, so we wrote rho sub W. Now we should write rho sub oil. Oh, gravity is the same, and the depth is 2, H2. Great. Then let's go from point 3 to point 4. So we go through mercury, Hg. Okay. And so from point 3 to point 4, the total displacement is from here to here, and we went upward, so it's H3, and it's upward. Based on the rule, if you go in the opposite direction as gravity, it was downward, and here we went upward, so we deduct the hydraulic pressure. Minus rho, we went through what? Oh, Hg. Rho H GH3. Where are we now? Where are we? We're at point 4. Okay, great. So equals 0.4 P4. That's it. That's all we need to know. That's it. Keep in mind. Now, it's a good trick here to stop, take a breath, and I mean like the first time, not on the exam. Take a deep breath and just think and just review that what am I looking for exactly, because I don't have it sharp in my mind. What was it? Oh, I was looking for the gauge pressure P1. So please do this when you are solving an example. Please just pause for a second and in the middle of the way and think about what are we looking for, right? Because you might like get like led toward another point and you totally miss what you were looking for. Okay. Anyway, we were looking for point 1. See, I forgot. We were looking for the pressure, the air pressure, the gauge pressure, and we know that it's the air, so the pressure is equal to the pressure on the interface up on the water interface. So we said that's point 1, and great, that was point 1. So we are looking for P1. Okay, here it is. Oh, here it is, point 1. Okay, good. Now we know, as we summarized here, that we know that P1 is equal to what we are looking for, and P4 is atmospheric pressure. So all we need to do is just to substitute these new parameters. So P1 is P air gauge, what we were looking for. So now I can keep it easily in mind that I was looking for this guy. Oh, hold on a second. Do I know how much is P atmospheric pressure? The water, let me see. Tank is much. No, it's not mentioned. So okay, I know P atmosphere. Oh well, wait a second, but it's not provided. So I'm not supposed to use this, because if I was supposed, then the question would tell me. So what should I do? This is what you should do. Do not assume P atmosphere. Think. Here I am talking about gauge. I'm talking about gauge. So P1, right? P1 is the absolute pressure, right? Oh, sorry. Oh my God. This is the absolute. All the pressures that we talked about. Sorry. Oh, my mistake. Sorry. I'm so sorry. This is the absolute pressure on the interface. Point 1, P2, P3, P4, rho, GH. Everything was absolute. Okay. Oh, we are still looking for this, because then we can. So do not assume the P. Do not look for this, the value of the P atmosphere. So what I know based on the lecture notes, P Sorry. What I know is that P gauge, P air gauge equals P air absolute minus the atmospheric pressure. Okay, so if I take the atmospheric pressure to the left and the rest of the terms to the right side, then I have P air gauge equals, take these three terms to the left side. It's G times rho Hg H3 minus rho O H2 minus rho WH1. Okay, great. Now all we need to do is just to substitute the values for all these parameters. Please keep in mind that you need to carry all the units all the way to the end of your calculation. So G is 9.81 meter per second square times rho Hg, it's 13,600 kilogram per meters cube times H3 is 0.3 meter. You can check it on the figure. Minus oil 850 kilogram. And then water at the end. H1. And the answer is 36,400 kilogram per meter second square. Okay, great. So we found the answer. But if you look at the question, it asks for the gauge pressure, air gauge pressure in kilopascal. So we need to convert our unit at the end. So please check the page, the lecture number 2, page 4, and then you can come back to the lecture. You can pause here and then come back later. Okay, now we're back. So we know that 1 Newton equals 1 kilogram meter per second square. So if I divide both sides by meter square, then I have 1 Newton per meter square equals equals 1 kilogram meter per second square divided by meter square. Therefore, I know that 1 Newton per meter square equals 1 kilogram per meter second square. Awesome. This is exact the same unit that I had here, right? So I can substitute the unit. So P air gauge equals 36,400 Newton per meter square, and this is defined as Pascal. So and kilopascal would be 36.4 kPa. So this is the final answer. So in your test, please draw a box around your final answer. That would be easier for me to find your final answers. So this is the whole lecture for the first example on manometer, and I will solve another example in the following lecture. Thank you for watching.